Hello everyone. Um, I'm just doing this little project basically to show how 7 segment LED displays work. There's a project I'm going to try and sort of work with from my one of my favourite YouTube channels. So I thought I'd have a look at the LED display because I'll be writing some code. So let's call it Project X that we're going to do. Yeah. Let's call it Project X. And so what I want to do is just show you how these work and write some code to display some letters on it. So first, just a little bit about the 7-segment display. I'll bring up a circuit diagram to try and explain how they're wired up. Here we go. This is how we're going to wire it up. Normally, with a 7-segment display, you'd probably use a 7-segment display LED driver. This means that you only need 2 pins from your microcontroller to display your digits. But Project X is actually using the microcontroller to control the 7-segment displays. And the microcontroller, the Project X only has 3 digits, but I happen to have a 4-digit one, so that's what I'm using for this demonstration. Now, a 7-segment display will have the 8 connections for the 8 segments. Well, it's a 7-segment display. That's because 7 segments are used to display the actual number. But then there's also a decimal place, so that gives you the 8th connection. Now the one I have is a common anode. That means that all these LEDs for each, the A, B, C, D, E, F, G and DP, the anode are all connected together. And the anode comes out on the right, this side here. This is the anode connection. And we have one common anode for each digit. So each one of these common anodes, if power is applied to one of these digits, it will light the corresponding digit up. And of course the other end of all these LEDs are connected to their individual connection. So if we connect one of these to ground, it's going to light up that particular LED. I've done a bigger picture of one of the digits, so you can see how it's wired up. Each segment has one LED inside, and of course the anodes are all connected to the common anode. Then each other side of the LEDs are all connected to the individual wires. So I hope that sort of explains how they're wired up. So if let's just say, well, I have 4, so the way, because there's 4 there, but we've only got 8 wires coming out, actually each A on each LED, on each A segment are all connected together on the cathode side. Let me just show that. Let's just get this. No, I don't want no numbers. How's that? Right, let's just copy that. Oops, hang on, pressed the wrong button. Let's try again. Right, so copy that. Oh, I'm in the wrong thing as well. Try again. I had the wrong macros on my keyboard. Copy copy that, and we'll paste that. So paste one, so we'll have 1, and we'll have 2, and we'll have 3. Well, I'll do 3, but we've got 4. But basically what I'm saying is these will not be connected. So let's just go like that, like that. So if you can imagine in here what we have, this our A here will be connected to let's just move it down there. Will be connected to our A there as well, and our B there will be connected to our B there, and our C will be connected to our C there, and then our D, there we go, will be connected to our, let's just go there, our D there, and then we've got our E, that will be connected to our E there, and then our F, there we go, oh no, there we are, our F will be connected to our F there, and then we've got our G, which will be connected to our G there. So you can see the way I'm going here. So the same happens with this one. These, all the LEDs are actually connected, all the cathode side of the LEDs are connected to these connections, and all the anode sides are all connected together, and they just make these other connections here. Oh well, we actually just get that. So you can see that we've got only one set of A, B, C, D, E, F, and G and DP, and then we've got the common, 4 common anodes of each actual digit. So I'll just delete all that. Yes, and so we're going to need we need the 8, 9, 10, 11. So we're going to need 12 pins on the microcontroller. Now what I was saying before, what we'd normally use, if I just move our microcontroller out of the way for now, I'll just move that down there, and what we'll do is we'll pick this one. What we'd normally have is this max 7221, and what we would then do is connect our microcontroller just using 2 wires. We just need our clock and data in. This cable select, if we were just using one, we could just connect that straight to the VCC, and then this chip will be selected all the time. This, using one of these chips, actually enables you to actually use 8 digits. So we could actually add another one of these and connect the 4. These same, we still use the same wires here, but what we would do is we would add the other 4 to this digit 4, 5, 6 and 7. So we could actually use this chip to actually connect 4 more digits. But as I say, we are using, oh, I can show you the data. I did pull out the data sheet for this. Yeah, so there's the data sheet for the you can see that we have our microcontroller. It's showing 3 wires here, but the cable select, we don't have to have that microcontroller. That cable select is if you're going to use more than one of these Maxim chips. If you're going to use another chip, then you'll need a wire to select each chip. But one of these chips can actually control 8 digits. So, but like I say, we're going to use a microcontroller. So this is the way I'm going to wire it up. Basically, is use a microcontroller and connect it to the digital. Oops, no, it's not there. There we go. Did that wrong. Right, so yeah, I'm going to actually wire it up like that. But before I do that, put a microcontroller on there and get the microcontroller to control all these connections. Let's try and do it manually so you can get a better picture of what's going on. So I'll just move that out of the way. And there's my little board. So basically I've wired it up just, hang about, let's have a look. So, right, what we've got is, I've got, if we look at this board, you see these 8 white wires, those are my segments, and then these 4 yellow wires here, these are my digit wires, which if we look at the circuit, hang on, I'll just bring it back. If we look at the circuit, these are the segment wires, the 8 segment wires, and these are the 4 digit wires. So these are the orange ones and these are the white ones. Okay. So what I'm going to do is I'm going to connect them up manually. So what I've got is I've got some blue wires here, which these are to ground, and I have got a red wire here, which is to VCC. So if we add some power, like I say, if we these are the digit wires, they're for each individual digit, and then these the white wires, because I've got them going through some resistors there. We need some resistors with the diodes. These white wires will be the segments, and so if we look at the top there, that segment A, this segment A, and this segment A, and this segment A, they're all connected together. So I can show that by, if I connect a ground to, you can't see that, can you? So what I'm doing is I've got some connections there. What I'm going to go is along these pins here. So I'm going to connect segment A. Obviously nothing happens because I haven't connected one of the digits. So what we can do, because this ground is connected to the one side of all the A segments, this side is connected to the actual individual digits. We can select which digit we want to light. So if I wanted to light the first one, I would do that way. You can't quite see that. There, I would connect, that's this one here, and then if I connect this one, hang on, I need my glasses. Put my glasses on. Where are we? Yeah, there, that one, that does the next one, and then this one will do the other digit, and this one will do the other digit. Now if I was to change the segments, so if I can go to segment B, you can see it lights up segment B, and then if I change this wire, it'll change segment B, it'll light up segment B on the other digit, then the other digit, and then the other digit. So basically what this is doing is choosing which digit to light, and this one is, I'll go to the end digit so we can see that. Oh no, you can see that on the thing there. So we've got the one top of that digit. So this is doing the actual digits as I go along, and then this one is doing the actual segments. So I've got A, B, C, D, E, F, and G. I missed it. Oh no, it's decimal place. G and decimal place. So if we wanted to make a 1-up, what we would need is B, and we would need C as well. So I'll put C connects. So I've connected 2 up there, 2 of the segments, and this is still on the first digit. But if I wanted a 1 on this other digit, we would swap the digit, this one, for the digit, and this would put the 1 either on that one, or that one. So we can choose which one we do, and I'll just make it into a 7 by doing segment A. So there's a segment, made it into a 7, and now I can choose which actual digit the 7 appears on. So hopefully from that you can see, depending on which actual with this wire, which actual digit we've turned on and which actual segments we've turned on, we can put either a number here or a number there or a number there and number there. But the thing is, we can't do it all at once. We can't do all. If I was to try and let's just go back to 1 like that. If I was trying to light up 2, we could light up 2, but they would have to be the same number. You see, they both have to be the same number. But if we wanted a 2 here and a 1 there, what we have to do is light up the 1 there first, and then light up the 2 here by turning that one off. And this is what the microcontroller can do. The microcontroller can turn them on and off that fast that our persistence in vision will think that they are always on. So let's put in I'll get rid of them, and what we'll do is we'll put in a microcontroller to control them all. Just using one of these. Let me just add that. Now let me turn power off first in case I get it in the wrong place. Yeah, that looks alright. Right, so now I've put a microcontroller in there, and this microcontroller is controlling all the connections to these 4 wires and all the connections to these 8 wires. And so we should be able to make this look like a counter counting up. Let's try that. Just wait till it fires up. And there we go. Right, okay, now then, this doesn't, it looks pretty shit on the camera. Now this is because the camera has a shutter speed, and the camera is taking pictures to make the video in frames. So I'm sure we all understand how a camera works and a video works. So the camera is going that fast, it can actually pick out when some things are not lit. So it basically does not lit. And the reason why it's flashing like that is because up here I've got a light shining on it, and it's an LED light with a LED driver that has the power supply is just trying to think of the word. It has like a buck controller which controls it's a constant current controller, and so it's actually flashing it's an LED light flashing, lighting up this area, but it's flashing out of sync with these numbers. It's not flashing at the same rate as these numbers on here, because we're lighting these up, and what we're doing is multiplexing all these LEDs. We're only lighting one segment up at a time, or maybe, you know, we're only lighting one digit at a time, shall I say, of the 4. But it's going pretty fast, and the way the time that we're actually lighting these up is out of sync with the LED which I've got here, which is actually flickering. So I'm going to turn this light off and you'll notice the difference. There we go. Now let's see if we can get the bit better. There, now I've turned the LED light out, you can actually see it counting up the seconds. And that's what I actually see without the camera. But even if I turn the LED light on to shine on this to light it all up, I will not see it actually flickering, because our eyes have persistence of vision basically. And let's see if I can make that look even better. Oh yeah, just putting my hand in front there, look, that's the light from my room ceiling, but the light from my room ceiling is on the mains, which is AC, and so 60 Hertz isn't really affecting it. It's only the LEDs from my lamp that affects the but you can actually see that if I turn the light on, you can actually see that we're not actually lighting up all the digits at the same time, because it's acting like a strobe and it's out of sync with what we're doing. So if I turn the light back on again, let's get the brightness sorted out. Yeah, it looks like you can actually see that we're not lighting up each one at the same time. So let's have a look at the code. Where did I stick that? There we go. So here's our code. Let's just move that around. Let's have a look at the circuit as well, so we can see what we're talking about. Yeah, I think we just need to see that bit there, and we need to see, actually make that smaller. There we go. We can see the circuit and the code. In fact, actually, I'm just going to turn the we don't need this anymore, so I'm just going to turn this my phone camera off. So just give me a moment. Oh, actually, I'm just going to pause for a moment. There we go. I'm back. Right, so we've got our 7 segments. We've got our 7 pins for our segments, and then we've got our 4 pins for our digits. So first of all, we need to define our pins for the segments, which I have done here. These are our pin numbers. I've put them into an array because it makes things easy for later when we're actually switching pins on and off. If I can use an array, we can use a for next loop, and that way we can turn the correct ones off. I like to put a bit of comments in my code to help remind it. If you can see here that I've done the A, B, C, D, E, F and G and D, P, just so that it reminds me what I'm doing here, which pins represent which segment. Yes, so there's our segment, and then of course we have our digits. So I've just drawn 4 8s for our 4 digits, and this is number 1, 2, 3 and 4. So this is another array for those pins. So I've made another array with those 4 values in there, which is digit 1, 2, 3 and 4, which we've got up here, 1, 2, 3 and 4. We've also got our decimal point. Now I have, right, well, I'll tell you what, before I talk about that, let's look at this, our numbers. What the microcontroller needs to know is which LEDs to light. Well, actually, let's just move to the big one. Yeah, so to make up a number, let's make them bigger. Let's just go with that. Okay. See if I can make them numbers big. Oh, I don't want the whole thing. What am I doing? Pressing the wrong one. Oh, there we go. Let's grab that one as well. Yeah, let's selected items and the reference text size. Oh, it's in inches. Would be in inches. I'll have to change that. Let's try 0.2. See what that looks like. Yeah, that doesn't look too bad. Oh, let's actually let's go 1.5 and line width 0.02. Try that. Now make that bigger. What does that do? Oh, maybe that doesn't seem to have changed it, does it? I wonder if you have to do that. Maybe it's got try 2. No, anyway, having numbers bigger is just as good. I'll have to look into that. Right, so I'll just move them up. There we go. There, we can see it now, can't we? Yeah, so if we want to make a number 1, we need B and C on. So if we'll look, oh well, actually, let's start at 0. If we want a 0 on, we want A, B, C, D, E, and F switched on. So we have to tell it what we want switched on. So we can see there we've got A, B, C, D, E, and F switched on for that. For a number 1, we need the B and C. So we don't want A, we want A, B, and C. So we can see there we don't want A, so that's a 0. And then we've got B and C. And for a 2, we'll have the A, B, and then D, E, and F. So that basically we're coming down sort of like that. So hopefully you can see, and like I say, 3, we've got that one. Oh, there we go. We've got A, B, C, D, and G. So you can see that we've got all those lit there. So we've got 4 lit. Why? Oh no, there's G. There's G. There, look. Yeah. So we've got 4 lit there for making our 3, and so on. But instead, this number here, this one here. Oh, hang on, let's just alt. Right. So you see that value, that is our 8th bit, which is our decimal place. So I don't know, because I want to be able to move the decimal place, I've made it a separate piece. So I've decided, I made a constant in there, and I want to put the decimal point at 1. So basically that's going to go on, we're counting from this end on there. I know it's a bit confusing, but we go 0, 1, 2 and 3. And so I'm actually placing it at 1 here. So I'm going to put this decimal place on, in there, which is DP3. So what I've done is I've made this so I can actually change it and say where I want to actually put the decimal place. So anyway, that's that bit. And because this is because I put the pin numbers in an arrays, it makes it easy to define the pins. This in our setup, we're defining our 8 pins. We go from 1 to 8, and we define them all as outputs. And these these will be active low, so I want to send them all high. So I want them all to be turned off. So I'm setting them all high and turning them all off, and then I'm going to do the same for the other 4 pins, but these ones are active high, so this time I'm sending them all low. So that does my my pins for my segments and my digits. We have a loop. Now what I want it to do is I want it to count up to 9. I've only got 4 digits, so the biggest number we can stick in there is 9999. So I am counting from 0 to 99999, and then this next bit, I don't want to be switching the LEDs on all the time. It takes up too many resources, so what we'll do is we will refresh the display every so often. So I'm using the millis, and every 100 millis I am refreshing the display for 100 millis before we continue in our loop. So what it'll do, it'll stay refreshing the LEDs for 100 milliseconds, which is like a tenth of a second. So if I wanted to run for 1 second, I would put 1,000 in there, and I would move my decimal place across, so this would be the 1 second, but I've put the 1 second here, so that's why I put the decimal place here. And so then it displays the count that we're currently on. And this bit here is the important bit. This is what we'll need for our project X when we're writing the code for it, so that we can display the right values on the segmental displays. So what happens here is from this here, we're actually sending a value which could be anything between 0 and 9999 to here, and what I need to do is to find out which digit needs each number. So what we do, our digit 0, we have the remainder of 10, and then digit 1 has the value divided by 10, and the digit 2 is divided by 100, and the digit 3 is divided by 1000. So that gives us our 4 separate individual digits, and then all we do is we run through our four times the loop to do each actual digit one at a time. So we're only lighting 1 digit at a time. What we do is we turn them all off here. So we go 1 to 4, 0 to 4, well it'll be 0 to 3, but we go through all our digits and turn them all off. Then we select our number that we're going to use based on the current value, and then what we do is we turn all the segments on for that value, and if it's got the decimal place, if this value is the same as the decimal place I've picked, then we'll also light the segment as well. What we do is we add segments. Our segments, we add this one. What this bit does here, that bit does is add 1 into this slot here. So what it does, it pushes that, it changes this digit into 1 if we're going to use the decimal place, and it will then light that decimal place for that particular digit. and then we turn that digit on and we're able to see it, and then it returns and comes back again and does exactly the same and same thing over and over again. And it does this 4 times for each actual individual digit, but it's doing it that fast. We're multiplexing, we're actually just lighting each LED up for each number up for just a few milliseconds, and then we're lighting the next one for milliseconds, then the next one for a few milliseconds, then the next one for a few milliseconds. But our persistence of vision thinks that they're all on at the same time, and that's how it works. So I hope you found that interesting. I'm going to end it there. What I'll do is I'll make a part 2 as well. Well, I'll be making several parts for different parts of this Project X, and so our next part will be to do with what we need. Oh yeah, we need to add a knob that actually changes the values, so we need to be able to control what number is shown on this digital display. So our next part will be adding a rotary encoder, and I'll tell you how a rotary encoder works to actually display what number we want to display on this 7-segment display. We'll still be using this here because this is our code now for actually displaying a number on our 7-segment display. But next I will be adding code for an encoder switch, so when you rotate it we can increase these numbers on here by rotating, or decreasing the numbers, or set a number that we want by just rotating an encoder switch. So until then, I hope you found this interesting. If you've made it all the way to the end, thank you very much, and I'll catch you in the next one.